Hi there. Okay, so we're looking at 1.2 in your workbook today, and this is dealing with the Pythagoras theorem and how it's related to the tangent ratio. So when we're dealing with right angled triangles such as this, excuse me, there's two formulas we can use. One is the Pythagoras theorem, and the other is the tangent ratio. Now the tangent ratio is the opposite over the adjacent side. So if you're referring to this triangle and you're looking at one of the angles, and we're going to look at angle A here, the tangent ratio is the opposite side over the adjacent side. In other words, side A over side B. So if you remember from SOHCAHTOA, we can use SOHCAHTOA. We're actually using the last one here. Tan is the opposite over adjacent. So tan of angle A, whatever this angle might be, is equal to the opposite over the adjacent. So let me just scroll down, and we'll get rid of this. So we can abbreviate the formula as tan of angle A is opposite over adjacent, or in this case we're using side labels of A and B. Okay, so let's look at example 1. Let's use this diagram. We're going to calculate the length of the hypotenuse. Now, and also the measure of angle A. We want to measure this angle right here. Those are the two formulas we have to solve a right angled triangle are the Pythagoras formula and also SOHCAHTOA. So whenever we have two sides, we can always calculate the third using Pythagoras theorem. Look at the way the triangle is set up. This is angle A, angle B, angle C, and we'll label the sides typically as, if this is angle A, we'll label this as side A. This is angle B, we cross over and we label this side B, and if this is angle C, we'll label the opposite side over here across from the angle as side C. So side C here is the hypotenuse and it's the unknown, so we have to write out Pythagoras theorem like this: a squared plus b squared equals c squared, and it's the c that we don't know, so we fill in a, b, and we calculate c. So read through this and you can see the calculation is there on the page in front of you. The length of side C ends up being 4.6 centimeters. Second part of this was to measure angle A. So let's see how they measure angle A. That's right. So angle A, we set up, if you're trying to look for an angle in a right angled triangle, you use SOHCAHTOA, and in this case, because we've been given the adjacent and the opposite and the adjacent, we can use tan of the angle is opposite over adjacent. So just in the triangle above, I'll just scroll up, can't really see it, there we have it there. We can say that angle A, or tan of angle A rather, is opposite over adjacent. That means it's tan angle A, it's 2.5 over 3.9. Now that's tan of angle A. We want to have the value of the angle itself, not tan A, but just A. So how do we get rid of the tan? Got to get rid of the tan, so we do what's called an inverse function, the inverse of tan. So if we inverse tan this, it just gets rid of the tan. You don't have to do anything, it just becomes A. but that means we have to turn to our calculator and inverse tan the other side. So that's what this calculation is doing right here. And in doing that, we get an answer of 32.7. So that's telling us that the angle A is 32.7 degrees. So on the next page, I'd like you to try these build your skills at home while you're watching this video. Just you can get out a pen and paper and just try these, or just in fact do it right in your workbook, and just practice maybe one or perhaps two of these, just so you know you've got the hang of it. And then we'll just carry on with the video. You can pause the video anytime you like. So working with slope and the tangent ratio, this is where they connect the slope and the tangent ratio. We'll find out that the slope of something like this slope here, the hypotenuse, is related to the tan ratio of this angle here, x. So let's follow what they're saying here. In this triangle, the slope of segment xy, or side z, is, as we know, slope is rise over run. So this rise, x, over the run, y, the value x over y. Now we also know that if we're putting x over y, this is the same as the tangent ratio for angle x. Angle x here, tan of angle x, is opposite over adjacent, x over y. And that's what they're saying right here. Tan x is actually opposite over adjacent, or tan x is x over y. Now, you can see how these two formulas now are connected. The slope is x over y, and so is tan of angle x. So in other words, the slope is the tangent of angle x. And they're saying here that x, angle x, can be referred to as the angle of elevation. So what they're saying here is that in the triangle above, we can see the angle of elevation from the ground. If this is the ground here, the angle of elevation is from the ground up to the hypotenuse. In other words, the amount of inclination. You can see that as this angle gets bigger, obviously x is going to get bigger. This will rise up. This line will get ever steeper and steeper and steeper as the angle gets bigger and bigger. So it makes sense that the slope gets bigger. Slope gets bigger as x gets bigger, and the angle gets bigger. If tan of the angle will get bigger as the opposite gets bigger. So sort of makes sense there. So those are the two formulae you need to realize that are connected. The slope, this guy here, is rise over run, but tan of the angle of elevation, this angle right here, is also x over y. So looking at an example here, we want to find the slope of a hypotenuse as a fraction and use it to find the angle of elevation. Here's the angle right here. They're using the sign called theta, Greek letter theta, and we have to find the hypotenuse and also this angle. So, find the slope of the hypotenuse. Okay, so slope is rise over run, so 6.8 over the run of 4.2, so we have that. Now they want it as a fraction, so when you put 6.8 over 4.2, we can make that whole numbers. So decimals, get rid of decimals, multiply by 10 or 100, depending on how many decimal places there are. So here we'll multiply by 10 and it becomes 68 over 42. Now we can reduce. We can see these are divisible by at least by 2, so we can divide top and bottom by 2. We get 34 over 21. So this is the smallest whole number ratio for the slope. and use it to find the angle of elevation. Now remember, slope and tan of the angle of elevation are connected. So we can say that tan theta is equal to the opposite over adjacent, which is the same as the slope. So we have the slope. We can just put tan theta equals the opposite over adjacent, or tan theta is 34 over 21. And again, how do we get the angle from that? Because we just have the tan of the angle. So I guess we inverse tan both sides. This drops down just to give us the angle, and we have to inverse tan this ratio right here, giving us an answer of 58.3. Okay, so we'll just clear that. And building your skills, you can try one of these as you watch this video. Just pause and watch or try one of these in your workbook, and one or two. If you're getting it quite easily, that's great. So we'll go on to the next section here. We're going to run through this whole lesson. So example 3 here, working with grade. Grade's typically the same as a slope, only when you're driving along the highway, grade is a percentage. Okay, so when talking about the slope of a road, it's usually called the road grade, commonly expressed as a percentage. The steeper the road, the higher the percent grade. So here is the formula that can be used to calculate the grade. It's rise over run times 100. So let's look at this example. And example 3 is saying that Martin is driving along the Trans-Canada Highway. There's a sign indicating a 7% grade. What is the slope of the road as a fraction? And also find the angle of elevation of the road. So it's wise to draw a triangle. If you don't have a diagram, then draw one. So perhaps we will draw a triangle right here. Excuse my drawing. Okay, the grade 7% means a rise of 7 units for a run of 100. 7 over 100 is 7%, as you can see. They want the slope of the road. What is the slope? So what's the rise over the run? So simply 7 over 100. If we're told it's 7%, that's the answer. It's rise over run, 7%. Now find the angle of elevation. Now that means from the ground up to the part that's sloping, in other words up to the hypotenuse here. What's this angle? We'll call it theta, as they usually do. And remember, we need to think about this angle. We have the opposite, we have the adjacent, so we think of SOHCAHTOA and we use tan, and that's the part that's going to be shown in the next section here. So let's look at that now. So part B, we use the tangent ratio, and tan of the angle is rise over run. Opposite is the rise over adjacent, that happens to be the run, and that was 7 and 100 for this angle here. If we want the angle, we inverse tan both sides and we get an angle of 4%. So 4 degrees. So 7%, you can see that in traveling 100 meters, you rise 7. That's not really a very steep angle. So 4 degrees seems like a reasonable answer. Build your skills. So why don't you try perhaps one of these. Pause the video and try one. Another occasion we have, especially builders, to use slope is the slope of a roof, and roofs are built with all sorts of different grades. If you can think of being somewhere where it's going to snow a lot, such as Switzerland and the Alps, and even in the Rockies, if they're building a cabin, then the grade is rather steep so that the snow falls off the roof. If it's fairly a dry location, often they'll just have completely flat roofs with the drain holes in the top of the roof. But here in the west coast, we have, you know, an average grade to let the rain run off. Okay, so here the slope of a roof is often referred to as its pitch of a roof. A roof with a pitch of 5 to 8 is a roof with a rise of 5, run of 8. So 5 to 8, 5 over 8, rise over run. How wide is the shed in the diagram below? If the pitch of the left side is 3 to 4, the left side. Okay, so that's 3 to 4. This has a slope of 3 to 4. And the right side is a slope or a pitch of 8 to 9. And we want to know how wide the shed is. Well, we have this given to us as 3.2, and therefore we also need to add this length here that we've labeled L. Looks like we don't know the height, but perhaps we can calculate that. Without looking at the example, I'm imagining they're taking a ratio for this would be rise over run. So in other words, height, rise over run is the same as the slope they've given us, which happens to be 3 over 4. And we have to solve for h. Then what do you think we do? We really need this value L. And perhaps I should be letting you figure out how to get these two. But there I've given you how to get H. Can you figure out how to get L? You can pause here and just, before we go on, or look at your notebook, think about that for a moment. Okay, so let's go ahead and look at how it's done in the textbook here. Scroll down, and if I can get it all in, here we go. And yes, they set up this ratio to find H. Again, remember there's different ways to do this, but we can multiply the pair, 3 times 3.2, and divide by the spare, because 4 is not paired up. It's paired up with an unknown, we don't know what it is. So basically that's what they do right here. They take the calculation, they multiply both sides by 3.2 and by 4, and they calculate it out. So don't worry too much if you don't understand their way of doing it. Do it the way that's best for you. So they figure out H to be 2.4, and we're going to use this to find L. Now again, we've been told that this side of the roof here has a grade or a pitch of 8 to 9. We've now got the height of 2.4 and we need L, so they set up a ratio of rise over run, 2.4 over L is the same as the slope they've given us, 8 over 9. Again, multiply the pair, divide by the spare of 8. Or, the other way to do it, I always do it as a crisscross, top times bottom, 8 times L equals 2.4 times 9. And then we have to divide by 8, so divide by 8, divide by 8. The 8's cross out here, leaving us L equal to this calculation. And the answer ends up being 2.7. So we have to add that to the other side of the house, which we were told was 3.2. So adding these together, we get a value of 5.9 for the width of the shed. Okay, so why don't you try maybe number 9 here, and we've got practice your new skills. which you can do in class next day. And there's 8 here, so you'll do all those in class next day, but I want you to do the build your skills that you weren't able to do while you were watching the video. Okay, so that's all for this lesson. Thank you for watching.